Well, welcome everyone. My name is Nicholas Furman. I am part of the technical marketing team here at VMware in the Networking and Security Business Unit. Obviously a lot of excitement around the announcement this week in terms of what Pat talked about yesterday. So I'm here to put a little bit of rubber meets the road here and show you a little bit of what he announced, but actually show you guys how it relates to what we have in the product portfolio. I do want to let you guys know that some of this is things, I don't want to say it's things you have seen before, but we are trying to tie the story together. Obviously, many of you have heard for quite some time about the idea of having NSX everywhere, and really our ability now to sort of execute on that vision and have NSX sort of be this integral part of a lot of different products across VMware's portfolio. So. You guys are probably already familiar with NSX, so we'll go through what NSX is, but we'll also obviously talk about how NSX is part of some of the other products, the VeloCloud acquisition, and some of the things we're doing with cross-cloud and multi-cloud and the hybrid cloud strategies. Without further ado, I guess we'll get right into it. The way that this demo is structured, we sort of start with the end user and we sort of build the story all the way up to the public cloud. So we'll start with the end user then attaches at the sort of branch, the branch then attaches to the data center, and from there those data centers can either have workload existing inside them on-prem or could extend into some sort of public cloud environment. Obviously many of you heard about the announcements around Microsoft Azure, and we'll talk about Azure as a part of this demo today. So we'll get started first. Like I mentioned, we wanted to start with sort of what we're doing to enhance sort of end user experience. This is where the NSX SD-WAN by VeloCloud comes in. This first part is basically just showing a mobile worker, if you will, with their iPad or tablet, and how we integrate, again, the AirWatch component or the AirWatch managed service of having their iPad be managed by the AirWatch service, how that then gets amplified or optimized, I should say, with the VeloCloud software, and how that person that's experiencing an issue, we're going to address or solve that issue with optimizations with NSX SD-WAN. So the first screen here is basically just what the enterprise admin would see when setting up AirWatch. It's essentially configuring the integration directly from the AirWatch console to the NSX manager. So you see here there's an NSX manager URL. There's a username and password, and basically all we're essentially doing is once we enter that username and password and URL, we essentially take the security groups that are inside of NSX and we bring them into AirWatch. So all of the different security groups are configured here, and this is just basically showing direct integration between the AirWatch console and the NSX service that's running inside your data center.
Is that an import, or is it a living, breathing connection?
It's a good question. In this instance, it would be more of like a constant sort of update. So if additional security groups got added, we would be aware of them on the AirWatch side. It's not something you do once and then make a bunch of changes and then have to sort of import again. So that essentially is that, and like I said, what we're really showing here is that this end user's device, this iPad, happens to be managed by AirWatch. So when the user goes and wants to access their important sales data, what happens here is they basically get the spinning wheel that we all know and hate. Obviously, the user's experience is not that great. So the access to the resources in the data center have timed out, right? So what we want to show is how we can go and leverage something like NSX SD-WAN to sort of optimize those connections and take care of problematic issues that happen in environments between branch and data center. So things where you may see packet loss, jitter, latency, all of those sort of very network-centric things that affect usability or end user experience. So here we have the NSX SD-WAN by VeloCloud UI. We're basically going into one of the edges here that has two separate circuits or two separate connections. So there happens to be an AT&T connection as well as a Comcast connection that you can see here. And so what I'm doing is I'm basically clicking here in the UI and I'm bringing up, and you can see all different types of traffic characteristics. You can see throughput, you can see bandwidth, you can see latency, you can see jitter, you can see packet loss, you can see all information about those types or not those types, excuse me. You can see all the information about those specific links. What we basically want to do at the end of this is configure a policy that's going to prioritize the AirWatch traffic and fix the end user's experience so that something like a link that has high latency or is experiencing some sort of jitter is not going to affect the end user's experience. So one of the other things you can do before we jump in and configure that policy is essentially look at the actual live traffic happening on those links. So again, I mentioned we have a Comcast link and an AT&T link. We can go into the UI here and click this live monitoring button, and it will actually start to gather traffic statistics live as more and more traffic transverses the environment, right? So the top environment is the Comcast link. The bottom link there is the AT&T link. You can also click this little flag here to show very specific, again, network data, TCP and UDP flow details. I know this is kind of very much in the weeds, but I wanted to at least highlight the capabilities of the platform and what you can get from the UI.
And this data isn't synthetic data. This is actually watching the flow.
That's absolutely right. This is live data happening on those two circuits. So now what we want to do is we basically want to go in and we want to configure that policy that I mentioned earlier to essentially prioritize the AirWatch traffic. So we go into here, we click on enterprise branches, so we want to make this policy apparent across all the branches. So regardless if the end user is connecting at XYZ branch and happens to go to a different location, we want to make sure that the end user experience is no different regardless of where they connect. So we go in here, we click on enterprise branches, we're going to click on business policy, and we're basically going to go in and we're going to create a new role, like I mentioned, to create a new rule to go ahead and prioritize that AirWatch traffic. So I go in here, I basically am going to create a rule that's titled AirWatch. We'll go in and we'll click define, and this is basically just defining what application we want to prioritize. So here under our business collaboration category, we're actually going to scroll down and we actually have a VMware AirWatch profile, right? So we've selected AirWatch, we're basically going to hit OK. And with those few simple steps, now what we've done is basically created this rule that will prioritize AirWatch traffic over whatever link has the best availability and is not suffering any of those problems we mentioned earlier. So if there is a problem where there's high latency and high jitter on the Comcast link, the software will automatically prioritize the traffic and use the alternative link, thus providing the best end user experience. So if we click back over to the end user's iPad and we open the application again, now that we've assigned that policy within NSX SD-WAN, the user then loads the application and we get the spinning wheel for a second or two, but the information is now accessible and the connection doesn't time out. It's not using or trying to leverage those links that are suffering from some sort of issue, right? In our case, it may be high jitter, high latency, right? So that's the first part of this demo, just explaining how we can take the end user's experience and combine it with NSX SD-WAN and provide that value. The next demo that I wanted to go through and show you is sort of moving up the stack a little bit and talking about how we integrate the branches themselves with the actual data centers. So how do we provide, or I should say more specifically, how does NSX SD-WAN provide enterprise segmentation for all the resources in the data center? So the example being here, let's hypothetically say we want to set up a kiosk at our Tokyo branch as an example, but we want to segment that kiosk from accessing any of the resources inside of the data center that we don't want to have access to, right? So we have important HR information, we may have patient information, we may have all this type of data, but we have this kiosk in our branch and we don't want that kiosk to potentially access any of that data. So what we're going to do again is we're going to look at the NSX SD-WAN VeloCloud UI here. We're going to click on the Tokyo branch. We'll open it up, and again, the UI looks very similar to what we previously saw. In this case, we don't have dual links. We just have a single Time Warner link between our Tokyo branch and the actual main data center, which you'll see in a second, which happens to be in Washington, D.C. We can scroll the window down, and again, you get various information that we saw before, right? Categories of traffic types, operating system, sources, who's the biggest speaker, et cetera, right? So all information that a network operator is going to care about when they want to go in and diagnose problems or look to begin a troubleshooting scenario, although this is not really showing troubleshooting, this is more around segmentation. So the next thing we're going to do is we're basically going to go into the configure tab here, and we're going to go in and we're going to configure some parameters on our headquarters. Now, as I mentioned, the idea here is we want to deploy a kiosk at our Tokyo branch, but we want to provide the segmentation in our main headquarters data center, which happens to be in Washington, D.C. in this example. So we've accessed the part of the UI that's the Washington, D.C. headquarters. We're basically going to log in here. And we want the kiosk, because likely the end user that would be using a kiosk would be considered a guest, not somebody who's an employee of our organization. We actually have a segment configured in NSX SD-WAN by VeloCloud for that guest segment, right? So I've selected my Washington, D.C. headquarters, and now I'm logging in and looking at the information pertinent to that guest segment. Once I've selected the guest segment, you can scroll down and you can see a bunch of different information here. What's really relevant to us and the way that we're providing that segmentation is the BGP and routing information here. So what we're doing is we're basically going to create a peering from our NSX edge that runs into in the data center, and all the NSX components. All of you guys are familiar with NSX already, right? We have logical switches, we have logical routers, we have ESGs, edge services gateways. All of that is now tenant or segment specific. So you'll see in a second when I click over here to NSX, there is a specific ESG for the guest segment. And that's how the integration between these two platforms really works, because we're providing that enterprise segmentation, whereas the guest segment has its own separate logical switch, logical router, and ESG inside of NSX that is basically, providing that segmentation through the NSX SDDC. So let's take a look at what it looks like in NSX, right? So we click on NSX edges. We click on, so here's a list of all of the ESGs that are configured in here. As you can see, there's a separate edge specific to that guest segment. Like you saw in the previous window, there was a PCI segment. There's an edge for that PCI segment, et cetera. We click on the guest segment, and basically what we're going to do here is we're basically just going to add a interface on the ESG so that the BGP peering between what Velo knows about and what NSX knows about in terms of the resources in the data center, those routes now get populated to Velo, and we'll see that in a second here. So I'm basically just adding this interface. I'm going to add an IP address. I'm going to configure the BGP remote AS that you saw on the previous screen, and we're going to add that interface to the ESG. We'll publish the changes within NSX. And essentially now we have created that route advertisement so that the segments and the networks that we know about in NSX are now going to be populated into NSX SD-WAN by Velo. So we'll switch back to the VeloCloud UI, and basically
does that configuration have to happen for every edge device? Or is it something that can happen across the entire fabric?
Great question. Generally, it does happen for every edge device, but most people wouldn't do it manually like I did it. There would be some sort of automation or some sort of adding some sort of non-manual way of adding that interface to the ESG.
Okay, so it's not really baked in, but it's something you could automate.
Yes, and that's true of pretty much how we would do any sort of routing peering from that ESG to any sort of upstream router. In this case, it just happens to be the VeloCloud edge. So I'm just going to go back here to the VeloCloud UI, and basically in here what I'm showing you is that we're going to do a dump of the routing table for that particular edge for the guest segment. And what you'll see here, I've selected the guest segment, I click run, and basically what happens here is the routes that I have here, the 127 routes that are on the screen there, so 172, 16, 30, 20, and 10, are now learned from the resources in the data center, right? So what we've basically done is we've provided, and I should probably put a Visio up here in the future, but we've provided end-to-end segmentation. So now that the kiosk that's in our Tokyo branch is completely segmented from all the other resources that are inside the data center that NSX knows about. We've only allowed the resources from that kiosk in the Tokyo branch to the appropriate networks inside of our Washington, D.C. headquarters. It cannot access anything else, right? So it's that end-to-end sort of segmentation story.
So that's great for, I want to keep it isolated.
Yes.
What if I want to firewall it, filter it in the data center, and allow it to talk, but only talk to certain things?
You're setting me up for the next part, which is basically just going into the data center, and we'll show you how we can sort of set up firewall rules and sort of firewall the segmentation that we just went over is really sort of object level and sort of network type segmentation. But if traditional people think micro segmentation and firewall ruling, we're going to cover that in this part right now. So we've covered the end user experience, we've covered the branch and the branch segmentation into the data center. Now let's focus a little bit on the actual data center itself, right? So the next part is basically showing we have a application that we've deployed into the data center. In this example, it's an application that we call PlaneSpotter. PlaneSpotter is essentially made up of both a web front end, which contains, or I should say the web front end containers are running in Pivotal Cloud Foundry. The sort of app middle tier is also a container-based part of the application that actually runs in our Pivotal Container Service. And then the back-end database, which you see here, is just basically plain Jane, old school virtual machine that's running a SQL service. So the idea here is we've built an application that both leverages containers and virtual machines, but those containers are deployed in Cloud Foundry, PKS, and also traditional virtual machines running on ESX. So as an example here, we've logged into our vSphere client, and we're basically just, to give you a lay of the land, looking at what this SQL database looks like. So I've selected that particular virtual machine. You can note the ESX node that it's running on. You can note the IP address. You can note the logical switch. All of those important details that an admin is going to care about. What we want to do is click over or switch over to NSX, and we're actually going to start to look at these various components and how it all works together. So the first thing I'm going to do within NSX is I'm basically going to search for that particular virtual machine. So I'm going to type DFW MySQL. And based on that search query, you can see that it's found a virtual machine that NSX knows about. I'm going to select that virtual machine. And again, first thing you'll notice is the IP addresses that we saw in vSphere client match. The source is the ESX node that matches with what we just saw in the vSphere client. We're just basically correlating the data between what vSphere saw and knows about versus what what NSX knows about. The other thing that we do in our integration is we have especially to the question you just asked about around firewalling, is we leverage tags. So most of the objects, whether it's a container and or a virtual machine, we apply tags to, and then we can create firewall rules based off of those tags, right? So as opposed to create a firewall rule that says this particular virtual machine name can only talk to this other virtual machine name, we can sort of abstract it and make it a bit higher level, where we can say any virtual machine that contains tags XYZ can communicate or not communicate to any other destination, and we'll see that. But that's where it's important to understand the leverage and the scope of what we're actually using these tags on the screen for. So in this case, this particular virtual machine, the SQL database, has a tag database and it has a tag SQL, and we'll show you a little bit later where those come into play. So now we're going to look at the actual groups themselves. So we have these notions of what we call NS groups inside of NSX. And the grouping constructs are basically how we would say, okay, any virtual machine that comes up, or container for that matter, that comes up in the infrastructure with a tag that it says SQL database or tag that says database, we're going to put it in one of these groups. And then we can use those groups to create things like firewall rules, right? So in our example here, I'm just showing you, we have a group that's named PlaneSpotter DB. If I click on PlaneSpotter DB and I click over here on membership criteria, it tells you right there the membership criteria for that particular group is tag equals MySQL, scope equals app, right? So this is more of just a verifying of how all these components and these pieces work together. And if I click on members, the member that we just went through, which is that SQL database, is a member of that particular group. And you can see right there, that's the IP address that I showed you earlier on the previous screen. So now let's actually deploy the application and see what happens, right? So in the example I mentioned earlier, we're going to leverage a Pivotal Container Service to deploy the app component of our application here. So we can run a few basic commands. This is looking at some Kubernetes sort of low-level stuff. But what we're showing here is, by default, out of the box, Kubernetes has 4 default namespaces: default, kube system, kube public, and PKS infrastructure. What we do in terms of network automation with NSX and our integration with Kubernetes, anytime that you spin up a new namespace, we automatically create a dedicated logical switch and logical router for that namespace. So what this is basically showing you here is out of the box, we have 4 namespaces in our PKS environment. If I switch back to NSX and show you, you can see on the screen there that there are 4 logical switches per each one of those namespaces. So there's one for default, one for Kube public, one for Kube system, and one for PKS infrastructure. But that's not really that interesting. Let's actually deploy something and see what happens. So for most of you hopefully are familiar with what YAML is. YAML is yet another markup language, and basically YAML is the way that most people are deploying container-based applications today. So this is a YAML specification file for our app tier for this PlaneSpotter app, right? And it basically has what the app does, where we're pulling the images from, what each app does. You can see there's actually labels in here. So those tags that I showed you earlier that were on the virtual machine, based on this particular spec file, we're assigning tags to the containers. So once we deploy these containers and they spin up in PKS, they will automatically be assigned tag app equals PlaneSpotter, tier equals app tier. And I'll show you in a sec what that means. But I just want to show you this so hopefully it ties all that together. Let's go ahead and deploy the application. So basically we run a kubectl create command, and basically you can see very quickly we've deployed our PlaneSpotter app tier. And there's a watch command that we can run here to basically watch the containers being created, and like within 2 or 3 seconds those containers went from container creating state to status running. So basically we have built a container and deployed it in PKS. Now what does that mean for NSX? We go back to NSX, and if I hit my refresh button here, as I mentioned to you before, we build all of our logical networking constructs on a per namespace basis. So now that we've created a new namespace called PlaneSpotter, you can see now at the bottom of the screen that there's a new logical switch that corresponds with that PlaneSpotter app that we just deployed. And if I went up there and I clicked on routing, you have to believe me, there would also be a corresponding tier 1 router for that PlaneSpotter app as well. So that basically is how we do our integration, if you will, with Kubernetes. In this case, our Kubernetes distribution just happens to be Pivotal Container Service. So let me jump back now to the terminal window, and we're going to now deploy the actual front end of this application in Cloud Foundry. So the first thing we'll do is we'll just look to see what's in our current Cloud Foundry environment. We do a CF orgs. Basically, the only org we've created is called system. The next thing we do is we create an org called PlaneSpotter, so we're basically designating a new org within Cloud Foundry specific for this application. The next thing we'll do is basically create a dev space in our PlaneSpotter org. So now a developer can go and deploy containers in this dev space, and that's exactly what we're going to do here. So we're going to basically run a few commands here and basically do what is called a CF push, and we're going to basically push out based on a specification file and go ahead and build that front end, or I should say that container that will represent our application's front end. So here in 10, 15, 20 seconds, it's going out, it's pulling images from the internet, it's downloading, it's building Flask, it's adding Python to the container. It's basically building a web front end based on that specification file in Cloud Foundry. Once it completes, just like you saw in the Kubernetes integration piece, our Cloud Foundry integration works very similar. So once we've created a new org inside of Cloud Foundry, if I go back to my NSX screen and I click refresh, lo and behold, now I have a new logical switch and a new logical router that relate to the components that we just, I shouldn't say components, plural, the component or the container that we just built in Cloud Foundry. So you see right there, PCF, SD-WAN, PlaneSpotter 0. That is the new logical switch and the new logical router that the container that we deployed automatically attached itself to, and all of the networking components inside of NSX were automatically created for you. So going back to your question earlier about do people do a lot of these things in a very manual process, this is network automation at its finest, right? All of these components were automated based off of creating a container in Cloud Foundry or PKS. Nobody had to go in and manually create these objects.
How does this scale and the number of switches and routers and stuff?
Of course, we have scale numbers for the platform itself, and obviously there's scale considerations on how many pods you can run on a host, et cetera, and all of that is documented in our public scale docs. But It scales pretty well. I mean, one of the typical conversations we get talking to people about when we talk about containers is, this idea of running, I mean, the extreme case is some of the web scale companies or some of the search engine companies like Google, right, that, claim that they do millions of containers on a almost weekly basis. Generally speaking, we have not run into any enterprises to date running into major scale issues with the platform. And as we continue to release more and more, yes, the scale grows with every release. So with Pat's announcement with VCN, this also corresponds with a new NSX release, and those scales numbers from the previous release have jumped and gone up in the new release, right? Okay, so getting back to the last piece here for our on-prem piece so now we have a SQL backend deployed in a virtual machine. We have our app tier deployed in a container in PKS, and we have our web front end deployed in Cloud Foundry. How do we tie all this together, and how do we actually make the application function? So if we want to provide that segmentation that the gentleman at the end of the table was asking about earlier, we can do that using the firewall rules, right? So I clicked on firewall inside of NSX, and basically this is just looking at the firewall rule table. So there's a section here that says plain spotter microseg, and basically what we've done is we've gone in and we've sort of created all of the rules specific to this particular application, defining how the application should function. So I should be able to access the web front end from the outside world. The web front end should obviously be able to access the app layer, and the app layer should be able to access the back end database, but the front end shouldn't be able to talk to the database, right? So we're defining all of those actions and all of those rules in our firewall rule table. And again, we can define allow actions, we can define deny actions, we can define blocking actions. There's a lot of flexibility in terms of what we can do in defining our application. And this is just one application for a customer that has hundreds, if not thousands, of applications in there. You would see, significant sections likely for each one of those applications in the firewall rule table. In our example, we're just focusing on the plain spotter app. So I scrolled down just to give you an idea, and I've expanded the name field. So it kind of gives you an idea of how someone would actually architect or model these rules, right? So we're saying allow front end to talk to Kubernetes ingress, allow app to talk to DB, allow app to talk to Redis, allow the application to talk to the internet outbound, right? So you generally want to define all of those applications, and if there's something you want to disallow, you can obviously make that explicit rule as well. So that's the firewall ruling piece. The last thing we wanted to show, at least for the on-prem data center part, is how we actually provide these operational tools, or at least the operational consistency, now that we have potentially a data center that contains bare metal resources, a data center that contains containers, and a data center that obviously would likely contain virtual machines. Our tooling and our operational consistency doesn't change regardless of all those different workload types. So in my example here, I'm leveraging what we call trace flow, which is basically a nice pretty picture that says from point A to destination B, what is everything that happened in the path. So what I'm doing here is basically configuring a trace flow session, and I'm saying from a logical port that attaches to my plain spotter PKS logical port, sorry, to type plain spotter there we go. So my source is the logical port that connects to that PKS container. My destination in this case is going to be a virtual machine. In our case, we'll continue to use that same SQL virtual machine. And what we're basically doing here is we're showing how we can run a trace flow with a source of a container to a destination of a virtual machine. And like I mentioned before, regardless if you're doing, let's say bare metal to virtual machine, VM to virtual machine, or container to container, or container to virtual machine, the operational value of NSX is consistent, right? So again, to create this and make it, we have to inject some sort of traffic here. So I'm basically going to say I want to run TCP traffic with a source port of 10,000 to the destination port of, in our case, it'll be the SQL port, so 3306. And we're basically saying, again, from the container to the virtual machine, let's inject fake TCP traffic using a source port of 10,000 to a destination port of 3306, and let's see what happens. Let's verify that that container can actually talk to the backend SQL database, which in our case happens to be a virtual machine. So we click trace, we sit back for a moment, we let the trace go, and as I mentioned, the output is essentially this sort of pretty diagram on the left that gives you a hop by hop. So it's saying our source ESX node is ESX1. We've gone from the container to the PKS logical port, all the way up through the tier 0 central router, and then basically what it connects on the egress side. What are the objects along the way that connects to the actual virtual machine? And if the picture doesn't do it for you, on the right-hand side of the screen, you can actually get a hop by hop count here. So each one of these hops, we've captured not only what the direction, or excuse me, the actual action was, but we've also captured the actual the object name. So every logical switch, logical router, tier 1 router, tier 0 router, et cetera, that traffic goes through is now on this trace flow output. And again, in terms of understanding, this is a very simplistic example, but the reason why this is so important is one of the value adds, or one of the troubling problems that we've had many customers talk to us about, is providing a tool with this level of information and this level of visualization in the container networking space. So the example I just showed you was container to virtual machine, but if you're trying to get this level of information out of a system when you have thousands of containers and you don't really know where things connect, this is almost invaluable, right? I mean, this is one of the main value adds when we talk about operational benefits with NSX in the container space.
Hey, Nick, question. Sure. Is there a way to export that diagram?
We have actually, today, no, but we are driving, I don't think it made the release, but in a subsequent release, sometime later this calendar year, the ask for many customers was to actually export that into Visio, and we are driving that through engineering now. So it's not available in the current UI, but stay tuned. That will be something that we will continue to enhance as we move forward.
Okay, I had one more question. Sure. On with the configuration, since I don't know a whole lot about NSX, how do you back up your NSX config in the event that something happens instead of having to go through this manual process again? I didn't see any recovery option.
Yeah, great question. So there's a variety of different components that make up NSX. You basically have your UI front end, which is what we call the manager. Then you have your control plane, which are your controllers. And then you basically have your data plane, right? So your logical switches that run in each ESX node, right? You can basically, through the manager, export the entire configuration or a subset of the configuration. And then the inverse is true. So if disaster strikes and you have these objects or these virtual machines in your infrastructure, you can then re-import that configuration and then sort of restore it to its last known backup or export. So in terms of failure scenarios and in terms of when disaster strikes, we have most of that baked into the UI, and you can go ahead and recover from a failure if that catastrophic event would occur. Yeah, sure. Any other questions before we go on?
So I have a question about packet flow. Sure. So, with the inclusion now of the SD-WAN product and kind of bringing that into the fabric, typically in fabrics, right, you're going to have a border of some kind where traffic exits. So traditionally in an SD-WAN product, it would leave at the SD-WAN hub, yep. Right? Now we're bringing it in firewall policy, and other rules are being applied by NSX in the data center. So is that policy being pushed to the hub device, or is the traffic actually coming in and participating in the data center traffic flow and then exiting the border fabric from within the data center?
And you're asking that specific, just so I'm understanding, specific to these sort of visualizations? Like what?
So I'm just trying to get an idea of, like, as a packet comes into your data center. So these systems used to be separate and isolated, right? Like the idea is they weren't integrated together. So you'd hit that hub device. I could send traffic that was guest internet traffic straight to my firewall. It wasn't included in my data center fabric at all. You know what I'm saying? It just kind of went off, and then my data center traffic went to my data center. Now our policy is coming from the NSX orchestrator software that's sitting over the top of all of this, and the firewall policy seems to be applied inside of the data center fabric. So does that come in then and have to use the data center border to get out, traffic-wise, or does the traffic go directly where it needs to go?
So I think the demo is showing the firewall will be in the data center. Yes. The SD-WAN carries the segment all the way from the branch to the SD-WAN hub in the data center. And each segment is separate, and then Nick showed the handoff to the separate edge domains in the data center, either isolated or you can use the firewall rules to allow certain cross traffic.
That is true, and the other thing that I didn't show in this particular demo, but there are some firewalling capabilities that were existing in the Velo pre-acquisition product, and as we move forward, it's not there today, but I would expect to see some merging of that. But today, obviously, like you said, what we've focused on was primarily on the sort of, at least for this particular section, the traffic that's inside of the data center, as opposed to providing the you're talking about like perimeter firewalling.
Yeah. So when I guess the difference in the model that I'm seeing now is the fact that traffic that before might have never entered your data center fabric, right? It just came into your hub site and maybe went off straight to the internet. Now, because of these products are integrated, is now entering your data center fabric.
No, security is complicated, right? You have different models. So even with the Velo product, you have policies that may be native on the Velo product. You have insertion of Palo Alto networks in every branch office or Fortinet or Checkpoint through partners. And then you have the data center, which is the same. You have service insertion of partners there. The demo here is tries to show kind of the end-to-end demo, but it's a very simplistic model where traffic goes to the data center, you apply the policy there. What will happen is that most of the traffic that you see that would go to the internet that would never come to the data center, will still do the same because Velo is going to apply the native policy capabilities or the Palo Alto network capabilities. And then the one that reaches the data center will be labeled in a way that now hits the policies of NSX. So it's multiple layers of perimeter. It's not that the whole traffic does in a hub-and-spoke model. It's still kind of a constellation where many points can apply policies independently.
Okay, so policy does get pushed and applied at places other than the actual, even though it looks like we're applying the firewall policy inside that data center component, that those components, or at least some of those components, can be pushed out either to edge devices or hub devices.
It's one of the main value propositions of the NSX SD-WAN by Velo, because basically in most branches that represents the perimeter itself and how you protect the branch. So you have the policies on the firewall, even for the incoming traffic from the internet itself into the branch.
Yeah, sure. Okay.
Okay, so that is the on-prem piece. The next piece that we want to extend out is basically showing how we can take that similar concept of what we just learned from PlaneSpotter, and as opposed to run all of the components internal to our own on-prem DC, we want to look at how those components could potentially run in something like AWS or Azure. Obviously, Azure is of interest because of the announcement. So,
can we get your diagram older to put a little link into Australia, because we have an Azure region down there.
Yes. We will make sure it gets updated. So all we're basically showing here is how we've gone in here, and we're basically looking at the clouds that we've defined. So in our example, we have an AWS cloud defined, and we have an Azure cloud defined. And basically what we're going in here is just taking that same application that I just showed you how to deploy on-prem and minusing all the actual deployment pieces of it, and just showing now that the app tier can essentially run in AWS or in Azure. So we're in here, we clicked on AWS, we're looking at our instances, we're going to basically just look at all the VPCs that have the components that relate to our particular application. So I've selected my hybrid VPC, and basically here in the dropdown you can see that I have PlaneSpotter AWS Web 2B, Web 2A. Those are the web front-end services or web front-end servers actually running in AWS in this instance. And if I go through and I click and I basically do the exact same thing for Azure, we have the same thing running on that side as well, right? So we click on our Azure cloud, we click on instances, and basically within our configured VNets, you can see here that I have PlaneSpotter Azure Web 2A and PlaneSpotter Azure Web 2B, right? So those I basically, for lack of a better term, decommissioned the web front end from running in our Cloud Foundry instance on-prem, and I've basically pushed that web front end, and now it's running in public cloud. So when we go to access our PlaneSpotter application, you will actually be hitting a web server running in public cloud as opposed to it running on-prem. And this is just a couple screenshots real quick just to show what that looks like within NSX, right? So I'm in NSX, I'm going to search for all the available machines or virtual machines that NSX is aware about that contain the name PlaneSpotter, and you can see there Web 2A is running in AWS. I click on it, and basically those tags that I mentioned to you guys earlier that we do a lot of our firewall policy on, you can see that we also use tags when we have the machines running in public cloud as well. So there's AWS tags there, and then basically if I look at one of the web servers running in Azure, we can go ahead and look at the tags that are associated with the web server running inside of Azure. So that's the public cloud piece. The last part of the VCN message that I just wanted to highlight for you guys is sort of the migration story. So how do we take workloads that are running in our on-prem VMware cloud and potentially migrate those to, let's say, VMC in AWS as an example, VMware Managed Cloud in AWS. So here we have an on-prem data center. It happens to be in London, right? And basically what we have here is a whole bunch of Ubuntu servers, right? And we're going to select a subset of those Ubuntu servers, and we're going to migrate them to VMC running in AWS. So what I'm going to do here is I'm basically going to log into, I'm going to select my Hybrid Cloud Extension tab in my vSphere web client. And basically there's a bunch of information here about how the extension works, the tunnel that we've set up, the tunnel's up, it's active. We basically built a tunnel from our on-prem London data center to VMC running in AWS's West region, I believe it is, right? So you get a bunch of information, the tunnel's up, it's active. You can see information about the actual networks that we're extending. So the actual logical switch name that's on my on-prem side is here, and then the NSX managed logical switch that's in VMC on AWS is that destination network right there, and we'll see that in a few short clicks. To kick off the migration, it's literally as easy as clicking the migration tab. We basically go in here and we select migrate virtual machines. There's a couple of parameters that you have to specify before you can do a migration. Most specifically, they're all destination parameters. So what resource pool do I want to put these virtual machines in on the VMC side? What storage do I want those workloads to use on the destination side? We're going to thin provision our virtual machines, and we're going to do a bulk migration of virtual machines. So once we've selected those parameters, we can basically scroll down our list, and I'm basically going to select server, or I should say virtual machine 40, 41, 42, and all the way up to 48, and I'm basically going to migrate 8 virtual machines in front of you guys real quick. So we'll go through here, we'll basically select our 8 virtual machines, and once I've selected all 8, it will do one last minor check just to make sure that we've configured all the parameters correctly and there's no issue. Once the validation is successful, we can basically just click finish, and the migration starts. So what happens is here, and I've sped it up a little bit just for time's sake, but in the course of maybe 50 minutes to an hour, I have migrated my my 8 virtual machines, my 8 Ubuntu virtual machines that were sitting on-prem in my VMware data center in London to the my VMC instance running in AWS in the West region. So that's just scrolling down to verify that everything is migrated. Now we're going to go just check on the VMC side. So we'll go over here to our SDDC and VMC. You can see it's running in our US West region in Oregon. We click View Details, and basically we're just going to verify that, number one, the NSX components that we're obviously interested in are running in VMC. So we click on Network, and basically we see here very quick in terms of the management components that are running. We have a vCenter component running. We have NSX Manager running. And we'll scroll down, and that destination logical switch that you saw earlier, that L2E, that name that you saw, is basically here managed by NSX. So L2E underscore VMs with a bunch of random characters there, that is the destination logical switch that those 8 Ubuntu boxes are now sitting on, which is an NSX managed switch inside of VMC on AWS. So basically, just to complete the story, we're going to go back and we're just going to verify in our host and cluster screen here that our 8 machines have migrated and are running. So here's our SDDC data center in VMC. We expand the cluster. We expand the resource pool that we configured in the previous slide, or excuse me, in the previous tab. And we basically scroll down. And you can see there that Ubuntu server 40 through 48 have been successfully migrated and are up and running inside of VMC on AWS. And just to close the loop, right, I've selected Ubuntu server 40, and I'm verifying that it's actually on that correct logical switch that NSX has created inside of the VMC service on AWS. So that has sort of completed the entire story in terms of how we go from the end user's point of view to the branch point of view to the branch connecting into the data center, then what we do with NSX inside of the data center on-prem, and now what NSX is doing for workloads, hybrid workloads that are both on-prem as well as public cloud, and then obviously in terms of the migration conversation, how we can take those workloads and migrate them from an on-prem VMware or vSphere-based data center to in this instance, VMC services running on AWS.